Hey everyone, so you asked for it. A deep dive into getting data prepped and ready for analysis.
That crucial but often overlooked stage of research.
Yeah, and today we're diving deep into Chapter 8 of that research methodology text you sent over.
Excellent.
We're going to see how researchers tackle, like, missing data, how they transform data.
Wrangling those outliers.
Oh, yeah. It's more exciting than it sounds, right?
It really is. Data cleaning, it's the foundation. We got to make sure that data is telling an accurate story.
That is so true, so important. So first up, missing data. It's like a fact of life for researchers.
Well, absolutely, a common headache.
Yeah.
Yeah.
And this chapter really emphasizes understanding, like, why is data missing?
Right.
They talk about MSOR, like, missing completely at random.
Uh-huh.
And then there's MR, missing at random. And this is related to other data we do have.
Right.
And researchers have to make assumptions about this missing data.
Right.
And these assumptions, of course, impact the analysis.
Absolutely. And the example they give of the IT outsourcing study, that highlights this perfectly.
Oh, tell me more about that.
They needed this data on IT expenses, but it was missing for some companies. So instead of just ignoring it, what did they do? They dug into financial statements.
Wow.
They used industry averages when they needed to. They got creative.
That's great.
It's like they didn't just throw up their hands. They found ways to fill in those gaps.
Exactly. And they were transparent about it, which is key for any research, right?
Absolutely.
Then there was this example, I think it was about intelligence and leadership,
Okay.
where they were missing data on IQ.
Uh-huh.
And so they're thinking, well, we can't just assume that this is missing completely at random.
Right.
So they did a bunch of tests.
Right.
And even after all that, even after those tests suggested that maybe the missing data wasn't a huge issue, they still reported their results in a couple of different ways, just to show the impact of those missing data points.
That's the gold standard.
Right.
They acknowledged the limitations.
Yeah.
Let the reader see the nuances. It was very thorough.
Very thorough, yeah. Okay, now let's move on to data transformations, where researchers reshape the data.
Right. Make it easier to analyze.
It's like giving the data a makeover, right?
Exactly. And there's this misconception that all data falls into that nice symmetrical bell curve, that normal distribution.
Right, right.
But as they point out in the chapter, that's not always the case.
Not always the case at all.
Especially, well, like when we're studying things like company performance, you get these heavy-tailed distributions.
Okay,
Think superstar companies.
right. Oh.
They're so far ahead of the pack, it's skewing the results.
Yeah, it's like trying to fit a square peg in a round hole.
Ah,
Sometimes you gotta reshape things.
exactly. Exactly.
And the chapter says that's often what data transformations are for, to make those non-normal distributions look a bit more normal.
Right, but it's not the only reason.
Sometimes they have to address, like, inconsistent data spread, maybe change the relationship between variables. But no matter what they do, transparency is crucial.
Yeah, that makes sense.
Yeah.
This study on, let me see, ego depletion and abusive supervision is a good example of this.
Okay.
They found that the data on abusive supervision was a little skewed.
Huh.
So they squared the variable to normalize it. Basically, it was like stretching out those differences at the higher end.
And you know what?
Cool.
Their findings held up,
Oh, wow.
even after the transformation, which really strengthens their conclusions.
Right, because it shows that their results weren't dependent on just one specific way of looking at the data.
Exactly.
Okay, the chapter also had this example about consumer boycotts and company reputation,
Okay.
using those Fortune 500 rankings.
Right, and those rankings can be statistically tricky because not every company is in the Fortune 500.
Right, right.
And the scores, they tend to cluster together. Totally. So to make better use of these rankings, the researchers, they got a little creative.
Okay, how so?
They divided the rankings into 3 groups. It was kind of like creating a gold, silver, and bronze for reputation.
It's a clever way to acknowledge those tiers within the rankings while dealing with the fact that, not every company even had a ranking.
Exactly. They found a way to make the data work for their research question
Right.
without, forcing it into a box it didn't belong in.
They were transparent, deliberate, and most importantly, they related those choices back to the core of their research.
I like that.
Now, are you ready to talk about something that always sparks debate?
Oh, I am. Hit me.
Outliers.
Ooh.
Are they bad data?
Are they hidden gems?
Right. And the chapter really emphasizes this. Outliers, they're more than just data to be fixed.
Interesting.
They can hold some seriously interesting insights.
Give me an example.
Okay, so think about it. Those outliers, those could be the star performers in a company, or companies that just defy the odds,
Oh, okay, yeah.
or even, those epic failures which, let's be honest, we can learn just as much from.
So true. It's all about context.
Exactly.
And I like that the chapter gives this helpful 3-step approach. You define the outliers, you identify them, and then you figure out what to do with them.
And transparency is key throughout this entire process.
Always.
How you handle those outliers, it can significantly change your results.
And the chapter provides like some really valuable guidelines, I think, recommendations for researchers.
Oh, absolutely.
Like they even have that handy decision tree in Figure 8.1.
Yeah, that's a great one.
It like guides researchers through this whole identification process.
Yeah, it's a great visual tool for a complex topic. And the first step is figuring out if you've got yourself an error outlier. These are data points that are way off, because of a mistake.
Oh, okay.
Like, imagine a typo in the data. Someone accidentally entered the wrong number. Stuff like that.
Right. But the chapter makes it clear that not all outliers are errors. You really have to investigate and figure out, like, why is this data point so different?
Exactly. And if it is an error, be transparent about how you addressed it, right?
Yeah.
Did you correct it? Did you remove it? And why?
Transparency builds trust, as they say.
That's right.
Okay. So if it's not an error, if that data point is far off but it's legit, it could be what they call an interesting outlier.
Right. And these are the ones you don't want to just toss aside.
Right.
These outliers, they can, challenge existing theories.
Oh, wow.
They might even point to entirely new phenomena.
Interesting.
Right.
Yeah.
Like, the chapter uses this example of researchers studying company acquisitions.
Okay.
And they specifically wanted to look at the extremely successful ones
Uh-huh.
and the unsuccessful ones.
Interesting.
Right. So instead of just focusing on the average acquisition, they're like, let's look at these extremes, these outliers. What can we learn?
I like that. That's smart. So the chapter mentions that you can study these interesting outliers in a couple of ways.
Okay.
You can, take a quantitative approach. You can really dive into the numbers, or you can go qualitative. Really explore the stories behind the data points.
Yeah, it's the difference between, looking at a map
Okay.
and actually visiting the place.
Oh,
The map gives you the overview, but being there, that's how you experience all the nuances firsthand.
That's a great way to put it. It's about choosing the right tool for the job, right?
Exactly.
Sometimes the numbers tell the story, and sometimes you need to dig a little deeper for that context.
Absolutely. But not all outliers are harmless.
Right.
The chapter also talks about these influential outliers, the ones that can really mess with your analysis.
Okay, yeah, I was just going to say.
They're like, imagine heavy objects on a scale. They can make your results look very, very different from reality.
Yeah, no kidding. And the chapter talks about handling these influential outliers in regression analysis, structural equation modeling,
Right.
multi-level modeling. They're all like different techniques, but it's the same goal. It's like figure out if those outliers are skewing the findings, and if so, what are you going to do about it?
Right. It's a detective case.
Yeah.
You got to identify the troublemakers, then decide how you're going to handle them.
Love it. So for regression analysis, the chapter talks about 2 main types of influential outliers. You've got your model fit outliers,
Right.
and you've got your prediction outliers.
Right.
So model fit outliers, they can either help or hurt your model's fit, depending on where they fall within your data.
And figure 8.3, that illustrates this beautifully.
Oh, yeah.
It shows how these different outliers, they can dramatically change the whole story the data is telling in a regression and analysis.
It really is amazing how much influence one single data point can have.
It's true.
So how do we even find these model fit outliers?
Right. Well, the chapter suggests you start by looking at those outliers you identified using multiple variables. You're kind of narrowing down the suspects.
Okay.
Right. It's like gathering clues to see which outliers are most likely to be causing all the mischief.
Okay. Love that. And once you've got your eye on a few suspects, then what?
Then you test what happens when you remove them from the analysis.
Ooh.
Right. And if removing that one data point significantly changes your model's fit, well, you've likely found yourself an influential model fit outlier.
Gotcha. So for example, the chapter talks about changes in the R-squared value.
Right.
So a big change after you remove a data point, that's a telltale sign.
Exactly. Now let's talk about those prediction outliers, the ones that mess with your ability to make accurate predictions.
Oh, okay, yeah.
They can throw off those crucial model parameters, like the coefficients that tell you about the relationships between your variables.
Right.
And to spot these troublemakers, the chapter suggests a few techniques. DFF-ICE,
Oh,
Books D,
DFBOTs?
those sound kind of intense. They might sound intimidating, but they're really just different ways of measuring how much a single data point is influencing the overall results.
Yeah.
And using a combination of them gives you the most complete picture.
So you found those model fit outliers or those prediction outliers. Now what?
Okay, so the chapter gives you three main options: respecification, deletion, or robust techniques.
Okay, so let's break those down. Respecification, that's kind of like what? Rearranging a room to make better use of the space?
Exactly. You're not getting rid of anything, you're just refining things. Maybe you're adding some new variables, maybe you're transforming existing ones.
Right.
But the goal is to better reflect the relationships in the data. And, as they point out in the chapter, this can sometimes lead to new hypotheses.
That's cool.
Because sometimes those outliers, they're pointing to something real that your initial model just wasn't capturing.
That's so interesting. It's like those outliers are trying to tell us something. Okay, so then there's deletion. And let's be honest, sometimes it feels a little bit like cherry picking, right?
Yeah, it's definitely a judgment call,
Mm-hmm.
but transparency is absolutely crucial.
Yeah.
If you're deleting outliers, you have to explain why you did it
Right.
and report your findings with and without them so that readers can see the impact.
Yeah, honesty is the best policy, right?
Mhm.
Okay, so the third approach, using robust statistical techniques. That sounds pretty hardcore.
Yeah, these techniques are built to withstand the influence of extreme values. Think of it like a sturdier scale that's less likely to tip over from a heavy object, right?
Okay.
The chapter gives examples like LAD regression and M estimation. They estimate the model's parameters differently, which makes them way less susceptible to those extreme values.
Wow, that's fascinating. Okay, so we've talked about regression, but what about those other net techniques like SEM and multi-level modeling? Is it the same kind of deal?
A lot of the same principles apply.
Yeah.
You're still on the lookout for those data points that are throwing off your results, and you've got similar options for handling them.
Okay, but it gets a little more complex, right?
Absolutely. In multi-level modeling, for instance, you often have data that's clustered in different groups. Like think about students within classrooms.
Okay, yeah.
So what's an outlier at one level might not be an outlier at another level.
So you're not just looking for outlier data points, you're looking for outlier groups.
Precisely. And the chapter talks about how, one single data point, it can actually cause a whole group to become an outlier.
Oh, wow. It's like that saying, one bad apple spoils the bunch.
Exactly.
So how do you handle that?
The chapter recommends a top-down approach. You start with the highest levels, so say departments within a company. You look for those outlier departments, and then you drill down to the individuals within those departments to see what's going on, what's driving that outlier status.
Oh, interesting. So it's like you're peeling back the layers of an onion.
Exactly. And again, transparency is key. Just like with regression, you want to explain your decisions.
Oh,
If you delete a group, if you delete a data point, say why. If you used a robust technique, describe it.
transparency for the win. The chapter also mentions DSMRs, deletion standardized multivariate residuals. They say those are especially helpful in multi-level modeling. What are those all about?
Right. DSMRs, they show you how much influence a single data point has on the variance at a higher level. So instead of just seeing how one student is doing, you see how that one student is impacting their entire classroom's performance.
Oh, wow. So it's like you're zooming out to get the bigger picture.
Exactly.
Okay, I think it's time to shift gears a little bit
Okay.
and talk about a practice that, well, it can muddy the waters a little bit.
Yeah.
Harking.
Ah, yes, Harkinging. Hypothesizing after results are known.
It's a little controversial, right?
It's a bit controversial.
Yeah.
Some researchers see it as this necessary evil.
Right.
Others see it as a threat to scientific integrity.
Right. And the chapter defines it as like adjusting your hypotheses after you see the data.
Right. It's like changing your answers on a test after you peek at the answer key.
Not cool.
Mhm.
And it makes findings seem a lot more impressive than they are.
Right. And way harder to replicate, which is a problem because replicability is, it's fundamental to science. It's how we build upon each other's work.
Absolutely.
And, the chapter actually delves into like the philosophy of Harking a bit. They talk about this thing called predictivism.
Oh, okay. What is that?
So predictivism is this idea that hypotheses that predict outcomes, those are inherently more valuable than ones that are developed after the fact. So it's like saying, a weather forecaster who predicts sunshine, they're better than a forecaster who tells you it's sunny, but only after they already see the sun is out.
Yeah, that seems a little unfair. Sometimes the best discoveries come from those unexpected findings.
Exactly. And the chapter acknowledges that view. which they call accommodationism.
Okay.
It basically argues that hypotheses shouldn't be judged solely based on when they were formed.
It's about being open to being wrong,
Absolutely.
refining your understanding as you gather more data.
Precisely.
Hmm.
However, the chapter also cautions that harking, it can lead to something called overfitting the data.
Overfitting? What's that?
So overfitting is basically when you create a model that's so specific to your data
Okay.
that it fits it perfectly, but it doesn't actually generalize to other data sets.
I see.
It loses its predictive power.
So it's like a custom-made suit that only fits one person.
Exactly. And this happens because with harking, you're essentially kind of twisting the data to fit your desired outcome.
And the chapter also raises another concern, that harking can kind of bias what's even considered like important and publishable.
Right. Because if researchers are more likely to arc their way to statistically significant results, well, guess what? Those are the findings that are going to get
It
published.
creates like a vicious cycle.
Exactly. Journals, they want those groundbreaking findings so researchers feel the pressure to deliver.
Right.
And then suddenly, studies that don't fit that mold, they're less likely to ever see the light of day.
Right. And then we end up with a very skewed view of what's true.
Exactly. It's like only showcasing the best parts of a city and pretending the rest doesn't even exist.
Yeah.
We need a balanced perspective to understand the full picture.
So true. And the chapter actually breaks down harking into 4 types, not all created equal.
Right.
Hypothesis proliferation, tharking, cherry picking, and question trolling.
It's like a spectrum of harking,
Right.
from the less problematic to the downright misleading.
So it's like there's levels to this harking thing.
Exactly. Some are worse than others.
Okay.
So let's start with the least worrisome one, hypothesis proliferation. It's kind of like, when you add guests to your party after it's already started.
Okay, yeah.
But they were already on the list.
Okay.
So you're adding some extra hypotheses after you've seen the data.
Right.
But only if those hypotheses stem from relationships you were already exploring.
Gotcha. So as long as you're transparent about it, identify those hypotheses post hoc, it's probably not a huge deal.
Exactly. Transparency is key, always.
Always. Okay, so what about tharking? That actually sounds like a good thing.
It is a good thing. Tharking stands for transparently harking.
Okay.
So it's about just being upfront about the fact that you adjusted your hypotheses based on what you saw in the data.
Oh, okay.
Right? Be like, hey, we thought we would see X, but instead we found Y. And here's why we think that is. And by the way, here's some new questions to explore based on this.
I mean, that makes sense. Research is a process. You learn things along the way.
Right. It really embraces that iterative nature of research.
Yeah.
Our understanding evolves as we learn.
Right.
And by being open about those shifts in our thinking,
Yeah.
we can help other researchers build on our work.
Yeah, and avoid those dead ends.
Exactly. Now, cherry picking and question trolling, those are a little different.
Yeah, those sound a little more deliberate.
A little more intentional. And these forms of harking, they're more likely to introduce bias because they involve actively seeking out the most favorable results, even if those results aren't super representative of what's really going on.
Okay, so give me an example. What would cherry picking look like in practice?
Okay, so imagine you're reading reviews for a product, right? And you only highlight the positive ones. You're hiding all the negative ones. That's cherry picking.
Okay, I see. So you're just showing the data that supports your point. Yeah. Now, what about question trolling? Is that next level cherry picking?
Kind of. It takes it a step further. So with question trolling, you're not just picking favorable data points.
Right.
You're picking your entire research question based on what you think will give you the most interesting, the most publishable results.
So you're looking for anything that sticks, even if it's just a coincidence.
Exactly. You're letting the data drive the questions instead of letting theory and prior research guide you.
That seems like a recipe for misleading findings, to be honest.
Yeah.
So what do we do about that? How do we combat those more insidious forms of arcing?
So the chapter gives some good recommendations.
Yeah.
One is just increasing your sample sizes.
Okay.
Larger samples, they make it a lot harder to cherry pick, harder to troll for results, because those random blips that can sometimes lead to these spurious correlations, they're just less likely to happen when you've got a bigger sample.
Strength in numbers, right?
Exactly.
Yeah.
They also talk about shifting the research culture to value replication studies more.
Yeah, I was just thinking that we need more of that.
Yeah.
Right now, I don't think there's a ton of incentive to go out and replicate other people's work. It's not as glamorous as doing your own original research,
Exactly. But replications are crucial. That's how we verify the findings.
Right.
And we need to be celebrating those studies that say, hey, that other study, yeah, their findings hold up. Just as much as we celebrate the ones that, discover something totally new and groundbreaking.
Absolutely. Journals have a role to play in this too, right?
Totally. They could implement like blind reviews of the introduction and method sections.
Oh, interesting.
So the reviewers are making decisions before they ever even see the results.
Oh, I like that. So they're not biased towards those like significant findings. They actually have to judge the study based on the strength of the research question and the methods.
Exactly. It's about shifting the focus from just finding something interesting to actually conducting rigorous, meaningful research.
Yes, I love that.
Even if the results aren't, going to be published on the cover of every magazine.
Right, exactly. It's about getting it right.
It is.
Okay, so we've talked about harking, but what's really kind of alarming is that even when harking isn't happening, there are these common statistical procedures that can lead to similar biases.
It's true. It's like finding out that your GPS is intentionally leading you astray.
Right, exactly.
Okay, maybe not intentionally. But certain procedures, they can be misused. Like the chapter talks about stepwise selection in multiple regression. It's where basically the computer is choosing the variables for your model.
Oh, yeah. That sounds so easy. Just let the computer do the thinking, right?
Right. Very tempting. But it can lead to overestimating the importance of those chosen variables.
Okay.
And it can make it really hard for other researchers to replicate your findings. Because you don't really know why the computer chose those variables.
It's like building a house on a shaky foundation. It might look good at first, but it won't take much to bring it all down.
That's a great analogy. And even just choosing your control variables, the variables that help isolate the relationship you're interested in, even that can introduce bias if you're not careful.
Really? How so? I always thought of control variables as being pretty straightforward.
They can be, but if you're testing out all these different combinations of control variables until you get the results you want, well, you're essentially question trolling.
Oh. It's like changing your outfit a dozen times until you find the one that looks best in the mirror,
Exactly.
It might make you feel more confident.
Right. But it doesn't change who you are.
Doesn't change the data.
Exactly. You got to let theory and prior research, not just the data, guide those choices.
Okay. What about with structural equation modeling, or SC? Any pitfalls we need to watch out for there?
So SCM has these things called modification indices. They can be super helpful, but you have to use them cautiously.
Okay.
So these indices, they can highlight areas where your model isn't fitting the data well,
Well, that sounds useful. So what's the problem?
It can be a really slippery slope.
Yeah.
Because if you start using those indices to just make a bunch of changes that aren't theoretically sound,
Yeah.
you're basically just letting the data dictate your theory, not the other way around.
Oh, I see what you're saying. Okay.
Right.
It's like letting the ingredients in your fridge determine what you make for dinner instead of deciding what you want to eat and then checking if you have the right ingredients.
That's a great analogy.
Right.
Because you might end up with a meal, right?
Yeah.
But it's not going to be what you were hoping for.
It's not going to be a good meal. Okay. So it's about striking that balance. We're using these statistical tools to guide us, but we're also using our own judgment or theoretical knowledge to make sure that we're not being led astray.
Precisely. And then finally, there's data mining, which is all the rage these days with big data.
Right. Everyone wants to be a data scientist.
I know. Uncovering those hidden patterns.
Right. But data mining is, just by its very nature, kind of a form of question trolling, isn't it?
It is. You're asking the data to tell you something interesting rather than starting with a specific question.
Okay.
One that's based on a theory or an observation.
So it's like going on a road trip with no destination in mind?
Yes,
You're just driving wherever it looks interesting.
exactly.
You might stumble upon some cool places, but you're also probably going to get lost.
It's true. We have to be mindful that just because there's all this data available, that doesn't mean that that's what should be dictating our research agenda.
It should be driven by our curiosity, a desire to understand things,
Right.
and we should have this theoretical framework to guide our explorations.
Absolutely.
This has been quite the deep dive into data cleaning. It's been eye-opening, really.
It really has.
Yeah.
It's a good reminder that data doesn't speak for itself.
Right.
We have to handle it carefully, think about it, interpret it, in order for it to reveal its secrets.
We have to be like detectives. We're
Right.
looking for clues. We're following the leads. We're piecing together the evidence to try to solve this mystery.
And you know what? Sometimes the most intriguing mysteries are the ones that really challenge our assumptions. and lead us down these unexpected paths.
I like that. So the next time you come across a research finding, take a moment, right, to consider the data behind it.
Ask yourself, where did this data even come from? How was it cleaned? How was it analyzed? Were there outliers? Was there missing data?
And how might those decisions have shaped the conclusions? Because being an informed consumer of research means that you have to be a critical consumer of the data. You have to understand that data, it's not just objective truth.
Right.
It reflects the choices made by the researchers who collected and analyzed it.
It does.
And it's up to us to ask those critical questions and keep digging deeper
Keep learning.
to uncover the full story. This has been The Deep Dive. We'll catch you in the next episode.